And this is going to be the 4th page of SAT 9 Extra Math. Let me just show the link again. I'm pulling this from this test. Again, this is part 4. So make sure to watch part 1, part 2, part 3. This is part 4 of this, the hardest math from this test. So we're jumping on to number 30 here, and another graph one. If you just watched the last part, we ended on a graph one. A lot of times graphs are easy problems, but they can make them challenging. So I'm going to have you can pause this for a second. Go ahead and analyze number 30. So I look at my axes. I said that in the last graph too. You really want to fixate on your axes. Hint. So I look through the problem and I see D is going to be the ice cream sales. That's fine. So I'm going to put D over here on the y-axis. And we have temperature. So they're saying there's a relationship between how much they sell depending on the temperature. 12 different days are my points. Which could be the line of best fit? So already there's a bunch of people. I would say almost every student that I've worked with, I don't know if I've ever seen get one right. They draw this line to here and they say my my y-intercept's probably going to be around 400. That's at temperature 10, not at temperature 0. So they're allowed to make these graphs that are extremely misleading. There's a reason why these graphs exist, because the data from 0 to 10 is obviously just not useful. So they get rid of that part of the graph. But in terms of our line of best fit, it can't be A or B, because our y-intercept is going to be way, way further to the left, right? So if I just try to do like a little bit of analysis here, I say, okay, at 16 for my x, we get about 600. And another point that's kind of close is this guy at 22. Oh, that was a really bad 0. Let's get rid of that. And at 22, we get about 800. So a change in 200 over change in 6, right? So 100 over 3, or about 33. So boom, they already got me there. But all I have to do is plug in a point, right, to get my y-intercept. So I just do y equals 33t plus my b here. And again, I take one of my points. I say 16, 600, 600, 16, and maybe try to estimate that. What's that going to be real quick? Good thing we can use calculators on this. 33 times 16, and I do minus 600. And it looks like we're going to be getting about 72-ish. Of course, I estimated a lot here, so that's just, oh, let me scroll down so you can see that too. Obviously, I estimated a little bit here, so it's going to be much, much closer to D here. So again, I don't think that one's too bad, as long as you are on the lookout for these tricky graphs. I figure out my slope, I figure out my y-intercept. It's really not too bad. And perfect. And what about, we have a geometry one. Geometry, usually it's what I hear the most complaints about, with being the most confusing. And I feel like it's because they can make them really abstract. They just have a lot of freedom with how they can manipulate these geometry problems. In my opinion, not my opinion, in my experience, looking at all problems, geometry makes up just the same percentage as any other type of harder problem, word problem, function problem, etc. But this one's good. So again, if you want to try it, pause it here. Let's see what they tell us, right? So the circle has a radius of 10. Okay. And that's it. That's all they tell us. So already, I had a student that drew a line straight down. And then they said, well, why would that help? Because like, I understand this part would be K in terms of my coordinate plane. But this lower part, I don't know how I would ever solve for that. So the most important thing on this test is building inclinations. What could be a relevant radius that I could draw here? And HK is my center. 4.0 and 20.0 are both endpoints on my circle. I'm allowed to draw a radius between my center and my endpoints, correct? And we'll get there. So we have a radius drawn. I know this is 4 or 10, sorry. And then I have this line here. That line looks like it's going to be a length of 16, right? This total line is going to be 16, but I want k here. So remember, in these geometry problems, there's going to be really important shapes, or specifically a shape that's going to help us with a lot of them, and it's going to be the triangle. Being able to figure out how to draw triangles in these harder geometry problems is going to save us. So if you think about it, k, again, is going to be, this is in my coordinate plane, it's going to be a line drawn down to my x-axis, right? Like if this is almost like a height, right? So if that's 6, the height of this triangle is going to be 6. And so this is k here. And then I know that the total length here is 20, and I know k is in my center. So I know this guy is going to be 8. And then already, you might have seen it, the most common triangle we are going to see on the SAT is the triangle that is the 3, 4, 5. And remember, sides of triangles, as long as they are similar, are relative in terms of like they can be proportional. So technically, I could have a 6, 8, 10 triangle, right? I see an 8, I see a 10. I know k is going to be 6 here. It really turns out to be not that bad, right? It's all about organizing. It's all about inclinations. Can I draw a triangle in my geometry problem, right? Another thing is, another triangle to remember is your 5, 12, 13, right? 5, 12, 13, just in case. So if you ever see two sides of one of these triangles, if I see 12, 13, I know the other side's 5, as long as it's a right triangle. Not bad. And I go up above here. Let's move me over. This could be a decent problem. So we have some context here. Oh, no, that's 34. No. So this is just its own problem. So again, pause me if you want to try to solve this. And let's do it. So all this kind of introduction information, I skip right down to the bottom. If one of these people who is a negative, so I already know we're looking here, is chosen at random, so it's these guys, the probability that the person has blood type B is 1/9. Okay. So I'm going to try to squeeze it in down at the bottom here. It's a long problem in terms of the height of the problem. So probability is what we want over our total, right? So what we want divided by our total. So I look at that and I say, well, there's 2 people. We know that that's 2. So I'm going to put 2 here. Over, and that 9 is going to be a representative of my total, right? So my total up above here, it looks like it's going to be 7 plus 2 plus 1 plus x. And I kind of just sum that up and I get 2 over 10 plus x. Okay, let me erase this stuff to kind of reevaluate here. So the chances of me picking someone that has the blood type B out of the negatives is going to be 2 out of 10 plus x. It's also 1/9, right? So I could just cross multiply these. Anytime I have 2 fractions with an equal sign, I cross multiply. I get 18 is equal to 10 plus x. And I already know x is going to be equal to 8 here. So I think this is a cool problem. I haven't seen too many variations of this one, but it's all about mastering every type of problem. Probability, what we want out of the total. I acknowledge they give me a 1/9, but I want to get my own equation from the table. My top, what I want is 2. My bottom is going to be my total. I add up all the people that could be there, set them equal to each other, cross multiply. Again, a pretty good problem here. This one is unique. So this is going to be 34 here. This is a very unique problem. Let's change our color. So again, pause me if you want to try to solve it. Okay. So first I want to analyze my axes, right? Number of goals scored. So that, again, I need to master these histograms, a lot of histograms. So I have number of goals scored. So this would be 1 goal scored, number of games in 8 games. So my first bar here is saying there was in 8 of their games, 1 goal scored. The next bar, 2 goals were scored in 9 of their games. And I don't have to add anything up. They say there's 29 total games. Awesome. I look down below. In how many of the games played in the 29 games did the soccer team score goals equal to the median number of goals? That can sound confusing. So in how many of the games did they score goals equal to the median number of goals? So right there, hyperfixate. Median number of goals scored in the 29 games. There's going to be a little trick for getting median. So I know that there is a total of 29 games, right? So I write that down below. What you want to do is you always want to round down to 28 and you cut that in half. So I get a 14 and I get a 14 and I get 1 in the middle. That's my median. I have to count up 14 and my 15th number is going to be my median. So that's going to be an awesome little trick. It always works. My 15th game is going to have my median. And what are even the data points, right? Well, there's going to be 8 ones and then 9 twos. That's already 17. So wherever my 15th number hit, it's going to be in my 2 column. I know that my median number of median number of goals is going to be 2 out of all my data points. And then I have to reread the question. In how many of the games played did they reach this median number of goals? And it's going to be 9. Perfect. So in 9 games, that's my answer. We've scored 2 goals. Pretty good problem, I think. And then let me just move this guy up here. So number 36, the final problem on this page. And what is going on here? So system of equations. I have 2 linear equations. I already have an idea of what I'm going to do. It has no solutions. We already know, right? We've seen this multiple times already. No solutions means they are parallel. 2 linear problems, they're parallel. There's an important lesson here, though. So I think on the last time we saw a problem like this, it was just an A. And we put it in Desmos because the answers were multiple choice. When they're multiple choice, you can use Desmos because I think on the last problem, the answer was like -6. Well, on Desmos, you can't really tell if it's parallel when it's -5.8, -6, -6.2. So them having answers that are like -6, -3, they're far enough apart that when it's multiple choice, you're fine. When it is free response like 36, I really truly think the best strategy is ignore Desmos. You're not going to be able to get or be super confident in an exact answer. Let's just solve it the normal way. And that is when there's no solutions, they have equal slopes, get them both in slope-intercept form, right? So I look at the first one. I already multiply it by 2, so I get 3/2. And I'll just add the y over. So -12 equals y. And then I'm going to put my x here. And then on the bottom one, same thing. Add the y over, subtract the 9. So ax minus 9 equals by. And then again, we don't care about the y-intercepts. We just care about slopes here. So let's get a different color. Divide both sides by b. So already, I know that my 3/2 is going to be equal to a over b. So even without Desmos, this is still super easy to solve. Even for the other ones, the multiple choice ones, do you need Desmos? Not really. It's going to be just how comfortable you are. Our answer for 36 is going to be 3/2. So yeah, this is part 4 of S18-9 extra math practice. If you missed the other pages, jump back through my videos. It should be in a playlist. But yeah, perfect.